How can a living, breathing creature allow its own heart to stop, let its bodily fluids turn to slush and ice, remain rigid as a stone for weeks on end, and then simply thaw out and hop away as if nothing ever happened? It sounds entirely impossible, like a biological magic trick or something pulled straight out of science fiction. But it is very real. Meet the wood frog, a tiny winter specialist that has mastered one of the most extreme survival strategies on Earth. When the deep cold of winter finally arrives, this frog does something unthinkable. It lets its heartbeat slow down and then, deliberately, fade to zero. Its blood turns slushy with ice crystals. The entire body goes stiff and rigid, feeling less like a living animal and more like a discarded, frozen leaf on the forest floor. There is no breathing, there is no pulse. Even the brainwaves, if you were to measure them, go completely quiet. By every normal measure of life, the frog looks utterly gone. And yet, it is only waiting. When the seasons turn and a warm patch of spring sun finally hits the forest floor, the frost on the leaves begins to melt. The ice within the frog softens, the skin gradually loosens. Somewhere deep inside that tiny chest, the first faint heartbeat returns, completely on its own. An eye blinks. The frog lifts its head from the damp leaves, and within a few hours, it rights itself, takes a breath, and simply hops away. This remarkable survivor is the North American wood frog, known to science as Rana sylvatica. At first glance, it looks quite ordinary. It is a small ground-dwelling amphibian, wearing a dark brown mask across its eyes like a little bandit. Its body is usually a rich chocolate brown or a muted tan, colouring that provides absolutely perfect camouflage for hiding among the fallen leaves of the forest floor. Most of the time, you will hear their peculiar, duck-like quacking calls long before you ever manage to spot one. But do not let that ordinary appearance fool you. The geographic range of the wood frog is absolutely staggering. They can be found from the temperate Appalachian forests in the eastern United States, stretching all the way up through the vast boreal woods of Canada and deep into the rugged interior of Alaska. In fact, the wood frog is the only amphibian you can reliably find living entirely north of the Arctic Circle in North America. They thrive in environments where winter is not just a season, but a dominant, defining force of nature. To understand why their freeze tolerance is so vital, you have to look at how they spend the winter. Most frogs avoid freezing entirely by diving deep underwater. They tuck themselves into the mud at the bottom of ponds and lakes, where the temperature remains safely above freezing all winter long. Wood frogs, however, do not do this. They overwinter on land. They simply burrow under a shallow layer of leaf litter and moss. Out in the open air, especially in places like Alaska, temperatures drop far below freezing. For the wood frog, escaping the ice is physically impossible. Since they cannot hide from the freezing cold, they have evolved to embrace it. Instead of fighting the ice, they actually invite it in, but strictly on their own terms. The frog has special nucleating proteins in its skin and blood that actively encourage ice crystals to form early, at temperatures just barely below freezing. This might sound counterintuitive, but it is a brilliant strategy. By starting the freezing process early and slowly, the frog ensures that the ice spreads in a highly controlled, orderly way, rather than as a sudden, catastrophic flash freeze. The golden rule of freezing living tissue is all about location. You can survive ice in the body, but only if it stays in the right places. Think of a bowl filled with delicate glass marbles, with water poured in to fill the gaps. The marbles represent the frog's vital cells. If you want to freeze the bowl without shattering the marbles, you need the ice to form exclusively in the water between them. That is exactly what the wood frog manages to do. The ice forms in the extracellular spaces, in the blood plasma and body cavities, while the inside of the cells remains completely liquid. This distinction is a matter of life and death. If ice crystals were allowed to form inside a living cell, their sharp, jagged edges would physically shred the fragile internal membranes and destroy the cell from the inside out. But because the ice remains entirely on the outside, the cells are spared. The freezing extracellular fluid actually acts like a sponge, drawing water out of the cells. The cells dehydrate and shrink down, but they keep their structural integrity intact. They ride out the bitter cold like a house tightly boarded up against a massive blizzard. To pull off this incredible feat of dehydration and preservation, the wood frog relies on a two-part chemical shield. The first part of this defense is prepared months in advance. During the crisp days of autumn, wood frogs begin to accumulate high levels of urea in their blood and tissues. Urea is a simple waste product for most animals, but for these frogs, it acts as a highly effective, natural antifreeze. By late fall, their baseline urea levels are elevated, providing a steady layer of protection before the first snow even falls. The second part of the shield is an emergency response, and it is spectacular. The very moment that the first touch of ice forms on the frog's skin, it triggers a massive biological alarm. The liver instantly kicks into overdrive, dumping colossal amounts of glucose, which is simply sugar, straight into the bloodstream. Within mere minutes, the frog's blood sugar levels shoot up by tens to well over 100 times their normal resting rate. In laboratory tests, scientists have found that the sugar concentrations in some vital organs reach truly astronomical levels during a freeze. This massive flood of sugar is not meant to be burned for energy. Instead, it acts as a powerful cryoprotectant. The heavy concentration of glucose works alongside the urea to gently pull water out of the delicate internal cells. As the cells lose water, the sugar replaces it, helping the vital proteins and cellular membranes hold their shape under immense physical stress. It is nature's perfect insulation. The cold constantly tries to push its way into the vital organs, but the thick, sugary syrup inside the cells prevents the remaining water from crystallizing into lethal ice. With its cells protected and its body cavities filled with solid ice, the frog enters a state of profound biological silence. This is not simply a deep sleep or a standard hibernation. It is a genuine, reversible state of suspended animation in a complex vertebrate animal. The heart completely stops beating, all breathing ceases, blood circulation halts entirely. The entire metabolic rate of the frog drops to a microscopic fraction of what it normally is. The animal essentially pauses its own life, waiting in a frozen twilight until the environment becomes hospitable again. The numbers behind this survival trick are truly astonishing. Classic biological studies, like the groundbreaking work published by researchers Kenneth and Janet Story in the 1980s, revealed that a wood frog can survive with roughly 60 to 70% of its total body water turned into solid ice. That means up to 2/3 of the entire animal is effectively frozen solid. They can maintain this suspended state for weeks on end, comfortably weathering ambient temperatures of -6 to -8 degrees Celsius. And they can withstand even more extreme conditions. In laboratory settings, these frogs have briefly survived temperatures plummeting toward -16 degrees Celsius. But in the wild, particularly in the harsh interior of Alaska, winter is rarely just one long, steady freeze. It is a brutal, unpredictable routine of stopping and starting. A sudden cold snap hits, and the frogs resting under the leaf litter freeze completely solid. A few weeks later, a brief thaw might sweep through, and the frogs soften, stir, and briefly wake up, only to be frozen solid again when the bitter cold inevitably returns. Field biologists have tracked individual wood frogs going through these intense, repeating freeze and thaw cycles multiple times over the course of a single, grueling Alaskan winter. Perhaps even more miraculous than the freezing itself is the process of waking up. In most vertebrates, including humans, if a tissue is deprived of blood flow and oxygen for a long time, the sudden return of blood causes massive, catastrophic damage known as reperfusion injury. But the wood frog is entirely immune to this. When the spring warmth finally penetrates the forest floor, the frog experiences a perfectly clean reboot. The ice slowly melts from the outside in. The massive concentrations of sugar and urea are gradually reabsorbed and diluted back to normal levels. Blood flow quietly resumes. The heart begins to beat again, spontaneously, without any need for a jump start. The brain wakes up without suffering any of the cellular damage that would normally follow such a massive pause in circulation and oxygen delivery. It is an incredibly delicate, perfectly timed awakening. Within just a few hours to a couple of days after the thaw begins, the frog's normal reflexes return. You might see a slow blink of the eye, a small flex of a back leg, and then a sudden energetic hop. The wood frog looks exactly like its old self again, showing absolutely no signs of the freezing ordeal it just survived. It is as if the long, brutal winter was nothing more than a deeply held breath, finally exhaled into the spring air. And once they wake up, they do not waste a single moment. Wood frogs are famously among the very first voices you will hear in the springtime forest. The males begin their loud quacking chorus, while large patches of snow and ice still rim the edges of the breeding pools. They are in an absolute sprint against time. Because they overwintered directly on land right next to the breeding sites, they can reach the water far faster than the frogs that are still waking up at the bottom of deep, muddy lakes. This early arrival is a massive ecological advantage. Wood frogs lay their eggs in temporary woodland ponds known as vernal pools. These shallow, transient pools are completely free of predatory fish, which makes them a safe nursery for the young. But there is a catch. Because they are temporary, these pools will completely dry up by midsummer. By waking up early and breeding while the woods are still half frozen, the wood frogs give their tadpoles the maximum possible amount of time to develop, grow legs, and hop out of the water before their temporary homes vanish entirely. Of course, this extraordinary strategy is not entirely without risk. Not every single frog survives the winter. If the season is too dry, the frozen frogs can lose too much moisture to the air and perish from desiccation. If a freak cold snap pushes the temperatures far beyond their safe limits for too long, the ice can finally breach the cells. But on a species level, this remarkable adaptation has allowed them to conquer landscapes that would instantly kill almost any other amphibian on Earth. Under a simple handful of brown leaves, a vertebrate animal allows the dead of winter to stop it completely cold. It does not run from the freezing temperatures. It does not hide at the bottom of a lake. It simply manages the ice, turning a lethal environmental threat into a perfectly calculated tool for survival. Through millions of years of extreme adaptation, evolution has written a masterful survival manual using nothing but sugar, urea, and immense patience. The payoff for that patience is a vibrant spring song echoing through a thawing northern wood. If this kind of clear, dramatic wonder in nature is your thing, subscribe and poke around the channel. We have deep sea hunters, extreme desert survivors, and many more odd biological talents waiting to be explored. Thanks for watching Faunary, and we will see you by the next pool edge.